Alrighty. So, what we are going to start with is that Pythagorean theorem. So, who remembers what the Pythagorean theorem is? You are absolutely right. A squared plus B squared equals C squared. Okay, this can also be written as like leg squared plus leg squared equals the hypotenuse squared. Okay, and this works specifically for right triangles. If the triangle is not right, it's not going to work out. We all remember that. Yeah. Do we remember what legs are called? Yeah, they're basically the smaller sides of a triangle. So this is a leg, and this is a leg, and then the hypotenuse is across from that right angle. Okay? Alrighty. So we also have the converse of the Pythagorean theorem. This is specifically when C is the longest side. And so what this converse says is if we get A squared plus B squared equals C squared, that means we have a right triangle. I just spilled coffee. Okay. But this can also get us other triangles. So if we have A squared plus B squared is less than C squared, anybody know what that might be? It is obtuse. It's an obtuse triangle. And if we have that A squared plus B squared is greater than C squared, that's going to be a what? Acute. Alrighty. So we also have what we call special right triangles. And so we have two of them. The first one is a 45, 45, 90. And so do we see how both the legs here are n? Yes. So the way we can solve this is we can say, well, we have a Pythagorean theorem. So n squared plus n squared is going to be equal to the hypotenuse, which is c squared, right? So we'd get 2n squared equals c squared. So then what would I do to solve for c? Square root. And so when I square root, that n squared will go away, and it'll just be given n. But what happens to that square root 2? Does it simplify? No, so it'd just be n times the square root of 2. So instead of having to do that every single time, this 45, 45, 90 triangle helps to give us a shortcut, because what will always be true is both of the legs will be n, and then the hypotenuse will be n times the square root of 2. Does that make sense? Okay. We also have another shortcut, and that is a 30, 60, 90. So when we're working with the 30, 60, 90, we are always operating off of the shortest side. So the shortest side, which is also the side across from that 30 degrees, that's what we want to work with. And so once we get that shortest side, the longer leg is going to be n times the square root of 3, and the hypotenuse is 2n. These are just patterns. You should have seen these before in geometry. Yes? Okay. So these are just patterns that you have to memorize. There's no, like, method of solving other than just memorizing. Alrighty, can I go? Perfect. So this says find all the missing links, even if not labeled. Leave your answers in simplified radicals. We're not really going to simplify the radicals. We're just going to leave our answers. So which type of triangle do I have here? Of the 45, 45, or 30, 60. It is right, but this is a 45, 45. Do we see that? So my advice would be to label our sides. We know that this is n, we know that this is n, and we know that this is n square root 2 from that pattern that we just saw a second ago. Do we all understand that? So that means I know that 9 is equal to n square root 2. So this would allow me to solve for n. How could I solve for n? Divide by the square root of 2. So when I do that, I get n is equal to 9 over the square root of 2. So that means both v and u are 9 over the square root of 2. Does that make sense? Okay, can I go to the next one? So which type of triangle do we have here? We have a 30, 60, 90. So again, across from the 30 degrees, that's our n. This is our n square root 3, and our hypotenuse is 2 times n. Do we all understand how I got those? Okay, so now we can solve for n by doing what? Yeah, so we know that 4 is equal to 2n. We get that from this side. So we'll divide both sides by 2. And so we'll get that n is equal to 2. So that means b would be 2. And then what would a be? 2 square root 3. Any questions? Wait, where's Michael? I told him to come back in.
He's probably just like maybe like put in the console. Should I go check?
Can you go check?
We told you to come back in. He's just sitting there.
Well, you missed the first part of the lesson. Real sorry.
This one.
Here you go. Alrighty. So, we've got a lot going on here, right? Do we see that? So we're going to take it piece by piece. We're going to take it one triangle at a time. So I'm going to start with this top triangle, right? And I'm actually going to take that and I'm going to bring it out here. I know, right? It is really nice. Copy paste. All right, and I'm going to bring it out here so that it's not as jumbled, right? So this is our 9 root 2. We know that this is 60 degrees. So what type of triangle is this?
60 degrees.
Yeah, a 30, 60, 90. So again, we want to write out what do we have. So this side is our n. This would be our n root 3, and this would be our 2n. And I'm going to give these some labels just to make our life a little bit easier. I'm going to call these that because we have to solve for all of these, right? So the nice thing is, do we see how n is already solved for? Yeah? Right, we already know what n is. N is equal to 9 times the square root of 2. So now we just have to figure out the other ones. So to figure out a, I would do 2 times n, which we know is 9 root 2. So what is that going to be? 18 root 2, right? We can only multiply it outside with outside and inside with inside. So we do 2 times 9, and then that root 2 would stay the same. And then for b, we would do, it's n times the square root of 3, so we know that n is 9 root 2, and we'll multiply by the square root of 3. So what is that going to be? 9 root 6, yeah. Okay, so we've solved that triangle. So then we can go ahead and we can move on to this one. Okay. I wonder, can I rotate this? I can. Wow. I like to draw mine vertically just because it makes it a little easier to visualize, but that is your preference, okay? So again, we know that this is a 45, 45. We know that this is y and this is x. What do we know that that hypotenuse is, though?
And
It's B.
It's b, which we know is what?
9 root 6.
9 root 6. Do we see that? That's what we got from the previous triangle. So we know that this is a 45, 45, 90, right? We know that because of this. So this is our n, this is our n, and this is our n root 2. I would advise on these, I didn't tell you this before, but color coding it, because otherwise you can get your n's confused. Does that make sense? Because we're using n more than once, so I don't want you to think that it's the same n for both triangles. Okay? So now what can I do to get x and y? What can I do?
Wouldn't it
Root 3 by 9.
So n root 2 is equal to 9 root 6. Do we see that? Again, we're getting that from this side. So to solve for n, what do I need to do? Divide by the square root of 2, right? So when we do that, n is going to be equal to what? 9 square root 3. And so that means that both x and y are going to be 9 square root 3. Questions on that? Okay. All right. Which triangle do we need to start with here? The top one or the bottom one? The bottom one. And the reason we need to start there is because we have a side length given to us there. So we have this 6. So we need to start with that one. Okay. So we know that this is 6. And we know that this is a 45, 45, 90. So again, this is n. This, I'm going to label these. Sorry, I forgot. A, B, C. Okay. We'll call this A and we'll call this B. We know that this is n, and we know that this is n root 2. So what is A? 6, right? Because we know again from this side that our n is 6. So A would be 6, and what would B be?
6 root 2.
Root 2. Ooh.
the sides are equal?
Yes, for a 45, 45, 90.
Okay.
Mm-hmm. Copy, paste. I love all my little fancy tools. Look at me. So fancy. All right, so again, we know that this is a 30, 60, 90, right? Different. We know that this is x, this is c, and this is b, which we just found, which is 6 root 2. Do we all see that? Okay. So which one of these is n? So this is n. Which one would be n root 3? X. And which, so then this one would be 2n. So again, for this triangle, we know that n is 6 root 2. So to find x, we're going to take 6 root 2 and multiply it by what?
6 root. Oh,
Square root of 3. So it's 6 root 6. Are we okay? And then to find c, we'll take 6 root 2 and multiply it by what? 2. So that would be 12 root 2. Does that make sense? Okay, can I go? All Alrighty. So it says let theta be an acute, this is meant to say angle, sorry, of a right triangle. The 6 trigonometric functions of angle theta are defined below. So who remembers back in geometry our little shortcut that we, SOHCAHTOA. So what SOHCAHTOA stands for is the sine of the is equal to the opposite over the hypotenuse. We see that here in this first one, right? And then we have cosine is equal to the adjacent over the hypotenuse. And then we also have tangent is equal to the opposite over the adjacent. Do we all see that? Okay. Now, those are all from geometry. So what we are adding to that are the ones at the bottom, and they each correspond with one on the top. So the first one is cosecant. Okay. It corresponds with sine. So if sine is the opposite over the hypotenuse, the cosine is just that flipped. So it is the hypotenuse over the opposite. I'm sorry, the cosecant. The secant corresponds with cosine. So if cosine is the adjacent over the hypotenuse, secant would be the hypotenuse over the adjacent. And then we also have cotangent, which shockingly enough corresponds with tangent. And so that is the opposite of tangent, so the adjacent over the opposite. So a couple of different ways to remember these. One way I weirdly remember is if you turn cosine around, it looks closest to secant. You know what I'm saying? Like COS, SOC looks closest to secant. The other way you can remember is each of the pairings should only have one co. So if you have sine, you have a cosecant. If you have cosine, you should have a secant. And if you have tangent, you should have cotangent. Does that make sense? So between the pairings, there should only be one co. Do we have any questions on those? So really, you just need to memorize SOHCAHTOA again, and then you need to know which one of these corresponds with which. Okay? So we are going to go ahead and do some work with this. So we want to work with this triangle, but what's the problem with this triangle? Yeah, we don't know the hypotenuse. How can I find the hypotenuse? Pythagorean theorem. So we'll say 3 squared plus 4 squared equals, I'm going to call this c squared. So what is 3 squared? 9. 4 squared is going to be 16. So we'll get that 25 is equal to c squared. So what is c? 5. Very good. So we are finding the exact value. So we're using this triangle. We see that this is our angle, this is our theta. So again, sine is going to be what? Opposite over hypotenuse. So what is the opposite? 4. So it's going to be 4 over 5. Cosine is the adjacent over the hypotenuse. So what is that going to be? 3 over 5. And tangent is the opposite over adjacent, so that will be 4 over 3. Okay, so again, all of those should be old. But now we're getting into some of the new ones. So cosecant corresponds with which one? Sine. So if sine is 4 over 5, what should cosecant be? 5 over 4. Secant corresponds with what? Cosine, so that should be 5 over 3. And cotangent corresponds with tangent, so that'll be what? 3 over 4. Yeah. Does that make sense? Somebody in my other class freaked out because they're like, that's a lot to memorize. I'm like, as long as you know SOHCAHTOA and you know which ones line up with which, it's really not that much. Does that make sense? All right, let's do some stuff with it. So sometimes you're not given a triangle, and it'll say sketch a triangle corresponding to this, and then find the other 5 trigonometric functions. Before we even start, there are 2 answers we can get here without drawing a single picture. Who knows what they are? Sine and cosecant, right? You should get sine, please. It's in the question. And then cosecant is just that, what? Reversed. So 5 halves. Okay, you just got 2 out of the 6 points. So then we draw a triangle. I love that I can draw a terrible triangle and it like autocorrects. Now, so when you draw your triangle, you can draw it like this. You could also draw it like this if you want to. You can put your theta here or you can put your theta here. It doesn't really matter. I draw it typically always like this just to keep it consistent. But that is your personal preference. Also, we do know that I'm saying theta. Okay, just checking. Like the Greek, yeah, okay. Somebody didn't know that, so I'm going to double check. That was good. All right, so if we have that sine is 2 over 5, this is the what over the what? Opposite over hypotenuse. So what do we know the opposite is? 2. And what's the hypotenuse? And how can we find the other one? Pythagorean theorem. So I'm going to call this, you can call it A or B. So we do 2 squared plus B squared equals 5 squared. So 2 squared is 4, and 5 squared is 25. So what is B squared? 21. So then B is going to be the square root of 21. Can I simplify that at all?
Yeah, well, yeah, with the, oh, no, that's not.
Yeah, so we could try, but 21 splits into 3 and 7, neither of which are couples or perfect squares or anything. Does that make sense? So we'll just leave it like that. So we have that this is the square root of 21. So now we can do cosine. So cosine is going to be adjacent over hypotenuse, so what'll that be? Over 5. And so secant will be? So then tangent will be what? Opposite over adjacent, and then we'll flip it for cotangent. Not too bad? I feel like the first part's worse. The 30, 60, 90 stuff.
Yeah.
All right, let's do this one. So again, we'll draw a picture. Okay, but we know that cosecant is 9, right? We were told that. So cosecant corresponds with what? Sine. And sine is opposite over hypotenuse, right? So this would be 1 over 9, yeah. But sine is opposite over hypotenuse. So this one is going to be hypotenuse over opposite. Do we understand that? And how can I rewrite 9? 9 over 1. So our hypotenuse is going to be 9, and our opposite will be 1. Do we all understand how I got that? Okay. So again, we have to find this missing side. So we'll do 1 squared plus b squared equals 9 squared. So we'll have 1 plus b squared equals 81. We'll subtract 1 from both sides. So b squared is equal to 80. And then we will take the square root of that. Now, we'll get that b is equal to the square root of 80. Can I simplify that? Yes, I can. And we can do a couple of different ways. I was going to do it the birthday cake method. Do you remember that? Yeah. Okay, well, we'll practice it. What's the lowest prime that 80 is divisible by? 2. Right? And that's going to be 40. That's divisible by 2, which is 20. That's divisible by 2, which is 10. 2, which is 5. And 5, which is 1. It's our candle. That's how we know that we're done. Aww. We've done that before?
Yeah.
Okay, it's just been a minute. And then our couples come out. So we have a couple of 2's here and a couple of 2's here. and they each come out like once, and we multiply them together. So this first couple of 2's gives us a 2, and the second couple of 2's gives us a 2. So 2 times 2 is 4, and then our singles stay home. So it's 4 root 5.
Wait, so we're multiplying the number that's in the circle times how many groups there is?
Yeah. So like these 2's only account for 1, 2
Okay.
when you take it out.
And then just multiply that.
Yeah, and then this is also a 2, so we'd multiply.
Okay.
Okay? Alrighty. So, now we can do the rest. So cosine is going to be what? Mm-hmm. And then secant would be, very good. Tangent? Mm-hmm. What about cotangent? Yeah, it'd be 4 square root 5 over 1, but we don't want to write it over 1. We want to just write it as 4 square root 5. Guys ready to try one? All right, why don't you do number 9? Did we get answers? Did we get those answers? What's up?
I have 15. So is it that wrong?
Yeah, remember tangent is opposite over adjacent. Does that make
I
sense?
have it wrong.
Gotcha. Right, so this is opposite over adjacent. So that means we have the legs here, so we'd have to find the hypotenuse here, as opposed to the previous one where we were finding one of the legs. Any other questions on that one? Alright, why don't you guys do number 10 as well then? Did we get answers? Do I need to wait?
81 minus 4 is 77.
Mm-hmm. That's what we should get. Whenever you finish. Questions? Okay, so next page is your homework. I'll give you the rest of the class to work on it. It is all 45, 45, and 30, 60, 90 triangles. We will use all of these other ones a little bit more next class. Just make sure you don't forget that this exists. Does that make sense to everybody? Okay, so I'll give you the rest of the class to work.